Hello, welcome to Samta Online Academy. In today's lesson, I want us to look at how to find theoretical yield and also how to find percentage yield. Now, in this case, I want us first of all to look at some terminologies that we need to be familiar with. So, for example, you need to be familiar with the meaning of the word yield, the actual yield, theoretical yield, percentage purity. We need first to define these before we take an example. So what is a yield? A yield is simply the amount of product produced when substances react. So when substances react, the amount of product that is produced is what you're calling as yield. And apart from that, we also have what we call actual yield. So actual yield is simply the amount of product obtained at the end of the reaction. This is simply the amount of product that you obtain when the reaction has taken place. That is the actual yield. So the actual yield is also called experimental yield. The actual yield is also known as the experimental yield. So take note of that. The other terminology that you have to be familiar with is what we are calling as the theoretical yield. Theoretical yield. What is this theoretical yield? Please, theoretical yield is simply the maximum. This is simply the maximum amount of the product calculated from the measured amounts of a given reactant using the balanced chemical equation and the Moore concept. Always take note of that. This is simply the maximum amount of product that you're going to obtain from your calculations, and these calculations are supposed to be based on a chemical reaction. So that is what the theoretical yield is all about. Okay, so what about percentage purity? What about percentage purity? So percentage purity is simply the ratio of the amount of a pure substance in the sample to the amount of the sample multiplied by 100%. So by using this definition, we therefore say percentage purity is equal to the mass of the pure sample over the mass of the impure sample multiplied by 100%. This forms the formula for percentage purity. On the other hand, we also need to establish the formula for percentage yield. So percentage yield is simply the actual yield. Let me write it somewhere here. So you can say percentage yield is equal to the actual yield over the theoretical yield multiplied by 100%. This is the formula for percentage yield. So please take note of that. Now, I want us to take an example so that we see how we can apply the formula for percentage purity. That's what I want us to look at in this lesson. Then later on, we shall also look at the percentage purity and how we solve problems related to percentage purity. Now, example. Consider the reaction below. Benzene reacting with chlorine to form chlorobenzene and the hydrogen chloride. This is the reaction that we have. So the question is saying when 36.8 grams of benzene, the formula is here, reacts with an excess of chlorine, the formula is here, the actual yield of the chlorobenzene is 38.8 grams. Question, find the percentage yield of the chlorobenzene. This is the formula here. So please understand the question. Now, here is what you need to take note of. What you need to take note of is that the actual yield is always given. The actual yield is always given. So the formula that I wrote here is this one here. So the actual yield is always given. All what you need to do is to find the theoretical yield, and this is obtained from a balanced chemical equation, and you see how we're going to do it. So let's go ahead now and answer the question. Let's go ahead and answer the question. Okay, so what we have now here is this. We are given the equation, which in this case now is benzene, which is this, plus chlorine, and this has given us a chlorobenzene, which is this, plus a hydrogen chloride. So let's see if the equation is balanced. So in terms of carbon you have 6, carbon you have 6, yeah, okay. Hydrogen, you have 6 here. Here you have 5 plus 1, 6 as well, balanced. Chlorine, 2, chlorine, 1 plus 1, 2. So everything is balanced. That's good. That's the starting point. That is the starting point. This is liquid, this is gas, and this is liquid as well, and this is gas. State symbols. So after you've done that, now remember, the question is saying that when 38 grams of benzene reacts with the excess of chlorine, the actual yield, so here the actual yield is given, the actual yield is given to be, the actual yield is given to be 38.8 grams. So this is the actual yield that we're given. This is the actual yield. So all what we need to do now is to calculate the theoretical yield so that we put in the formula and find the percentage yield. So how are we going to do that? Now remember, here we're going to do some equating. What you're told here is that this benzene reacts with the excess chlorine, and the actual yield is given as 38.8 grams. So you're saying find the percentage yield of chlorobenzene. So what you're going to do here is this. We're going to say benzene is going to be equated to this chlorobenzene, which is this, like this. So after that, you're going to find the formula mass of benzene as well as the chlorobenzene. So here, carbon is 12, that is the mass number, multiplied by 6, and then plus hydrogen is 1 multiplied by 6, like this, and this is going to be 12 multiplied by 6 plus 6, and this is going to give us 78 grams per mole. This is the molecular, this is the formula mass of benzene. You do the same here. Carbon is 12 multiplied by 6 plus hydrogen 1 multiplied by 5 plus chlorine is 35.5. That's the mass number. So I have 12 multiplied by 6 plus 1 times 5 is 5 plus 35.5. Altogether, when you multiply this times this plus that, you are going to get 112.5 grams per mole. So 112.5 grams per mole. So you found the formula mass of both benzene and chlorobenzene. So after you've done that, you can now do some equating. So what you're given here is, what you found here is 78, okay, of benzene, like this. You equate that to chlorobenzene, which in this case is this here, 112.5. Okay, so this is chlorobenzene, like this. So now you go back to the question. The question here is saying that when 36.8 grams of benzene, so you're given 36.8 grams of benzene. So that is going to be put here, 36.8 grams of benzene. And are we given the mass of benzene chloride? We are not given, so we're going to put X like this. So what we're doing here is we are finding the theoretical yield, because the theoretical yield is what you calculate from the balanced chemical equation. So we are calculating the theoretical yield from this balanced equation. So take note of that. So you simply cross multiply this times that, it gives you 78. X is equal to this times that, you have 36.8, then multiplied by 112.5, and therefore you simply divide here, so it remains with x. This and that will go, and here you have x is equal to this multiplied by this, and then divided by 78. What you're going to get is 53.08 grams. This is the theoretical yield of chlorobenzene, like this. So now we have the theoretical yield in place, and then we are already given the actual yield. So what we're going to do is simply to write down the formula now for percentage yield, and replace the values there so that we find our percentage yield. So remember, percentage yield is equal to actual yield over theoretical yield, everything multiplied by 100%. Everything multiplied by 100%. That is the formula for percentage yield. So percentage yield, therefore, is equal to, the actual yield was given to be 38, is there in the question. Let me show you here. The actual yield is 38.8 grams. So we're going to get that, and replace it where? Here. Going to get that and replace it here. 38.8 grams over. What is the theoretical yield? The theoretical yield is this one, which you're calculating from the chemical equation, which is balanced. So this is the theoretical yield. So you pick this. You say 53.08 grams multiplied by 100%. Okay, so percentage yield in this case is going to be this divided by this multiplied by that. You're going to get 73.1%. So this is the percentage yield of chlorobenzene that will be produced at the end, which the formula here is this one here. C6 and hydrogen 5 chlorine. So this is the percentage yield. This is the percentage yield of chlorobenzene. Okay, so I hope you've learned something, and please do well to follow me on my YouTube. Simply type Sakamuta Online Academy, then you'll be able to get hold of the channel. And please do well to subscribe so that you don't miss on such kind of amazing contents that we keep on uploading. And also please follow me on my Facebook page. Simply type Sakamuta Online Academy. You'll be able to get hold of the page, and please check there. We keep updating that page with a lot of videos like this, so that you'll be able to learn something. Thank you so much. Have a blessed day. Thank you.